Hey everybody, it's Derek Martin from CodeOpinion.com. Writing distributed applications like microservices can be really challenging. I know, I'm stating the obvious here, and that's why there's been a lot of push back towards a monolith. Because things like performance, versioning, testing, it can all be really challenging. But there's got to be some happy medium, right? Isn't there some type of tool we can use that we can write our code like a monolith, but distribute it like microservices? Service Weaver claims so. You can write your application as a modular binary and then deploy it as a set of microservices. So that means that you split up your application into a set of components. And then you call these components. That could be from component to component. And then you deploy those components to the cloud. And then you decide, okay, well, these components, they're going to be deployed together in a single process, or that could be spread across multiple machines. So this might sound great, but how does it actually work? What problems does it really solve? And then I'm going to challenge you with the question of, should you even have these problems in the first place? Before I jump into the ideas of Service Weaver, I'd like to thank EventStore for sponsoring this video. EventStoreDB is a new category of operational database built for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. There's a paper titled Towards Modern Development of Cloud Applications. The authors on this paper are many of those that I find related to Service Weaver, so I'm going to say that they're hand in hand. I want to read it and highlight a little part of this. When writing a distributed application, conventional wisdom says to split your application into separate services that can be rolled out independently. This approach is well-intentioned, but a microservice-based architecture like this often backfires, introducing challenges that counteract the benefits the architecture tries to achieve. Now, when I first read this highlighted part, I was cheering of joy. If you watch any of my videos, you'd understand why. Fundamentally, this is because microservices conflate logical boundaries, how code is written, with physical boundaries, how code is deployed. I couldn't agree more. But as I continued reading the paper, the cheering stopped. But I first want to touch on what Service Weaver does in acknowledging that physical boundaries aren't logical boundaries. And that goes back to the 4+1 architectural view model from Philip Crichton, and having different ways of thinking about your code. There's a logical view, there's a development view, which the paper is kind of conflating the two, and then there's a physical view of how you actually deploy your code. So as the paper mentioned of this conflation of logical and physical views, which I agree with, and typically what's been happening in the industry is that you have a logical boundary, the idea that you have some piece of your system that provides some type of functionality. And that usually turned into either that was a project, its own source repository, or something. Then you would take that code, you would build it, and you would deploy it independently. So there was kind of like this one-to-one-to-one. So as an example, let's say we have 3 different services. The source code for this could be even in a monorepo, but the idea is that you have this service that you're deploying to some unit of deployment. Let's say it's a container. So we have 3 different services, we have 3 different deployments of each in their own individual container. So that means that we have all of them communicating between each other. And if we're in a microservices environment, then now this all of a sudden turns into that we're communicating RPC over the network. What Service Weaver is saying is, hang on a second, just because you've written your code in 3 different projects, that they don't always have to communicate over RPC. That physical deployment aspect is a different concern, and we can decide how we want to deploy things. Maybe services we want to deploy together and that they're going to be communicating in process. Maybe we have another service where we need to scale it, we have multiple instances of it, and we're going to communicate it with it over RPC. So to illustrate this, we may have multiple services, service A and service B, but they're actually in the same process so that they communicate in process. But service C, we have multiple instances running, and they're going to be separate, and we communicate with those over the network in RPC. So at a high level, that might sound great, is that we just write our code like a monolith, and that we have these calls that they may be local in process, maybe say on our local machine, development machine when we're testing, but then in production, because we're deploying it a different way, some of those calls won't be local anymore. They'll be over the network doing RPC. So that might throw you back a little bit saying, well, hang on. Service Weaver's answer to this is that although it syntactically looks like a local call as you're writing it as code, you still, the developer, which I think is a great thing, are responsible for handling network issues, serialization issues. It kind of forces you down that path. So your mindset is thinking that it is going to be a remote call, but it actually could fall back to being a local call. But you're kind of put at the forefront for handling it, and you're responsible for it. So at the very beginning of this video, I asked, should you even have the problems that Service Weaver solves? I'm going to go through the paper again and show what the problems or the pain points that it's solving. But at the root of this, This all comes down to coupling, and not once in this entire paper did it ever mention coupling between components. So in the paper, the first issue with the distributed application like microservices and the pain point is that it hurts performance. And this makes sense. You're serializing, deserializing, sending data over the network, the latency there, especially too if you're making RPC calls between services. We have service A that makes an RPC call to service B. Service B then makes a network call to service C. And this could just keep going and it would be absolutely killing your latency. But what's the root issue here? You guessed it, coupling. Is that you have coupling between these components or services. And that's not to say that you're not going to have coupling, but you need to be explicit about what a component contains, what behaviors it has and capabilities, and how does it depend and couple to other services. You may decide in certain scenarios that you actually don't want to have that temporal coupling aspect at all, and you're going to use a message-driven architecture or event-driven architecture with queues and topics so that you're coupling instead via messages. You still have coupling, you're removing the temporal aspect, but that's a decision you need to make. The second issue it brings up is says it hurts correctness. And this is true if you have different services and let's say you make a breaking change, well, all that consumer client code also needs to update pretty much at the exact same time so that you're hitting the new APIs. Same things goes with events, or if you're using messaging, is that you need to be making backwards compatible changes so that you're not breaking clients. Yes, versioning is a pain in the butt, and dealing with different versions, backwards compatible, breaking changes, it's all a giant pain in the butt and isn't going to be hidden from you. Same thing, if you need to make some type of database change to your service, how is that going to work? Just because some other service is calling your new API, you still have some other service that's using your old API that you still need to make backwards compatible changes to your storage, for example, that's going to work. So it's not like this is just some magical, everything gets deployed atomically so that a request comes in that it's all using the same version. You have other concerns just besides your services, like your database that you need to contend with. And what's the root of this issue? Dealing with versioning between services? Coupling. In issues C3 and C4 directly relate to C2. C3 says it's hard to manage because you have these different release schedules. It's hard to test because you have all these different services. So running end-to-end tests of some workflow with all these different services locally would be a real pain in the butt. It freezes APIs, like I was mentioning with versioning, because you don't want to make breaking changes. So then you end up making changes for legacy, adding stuff on top. Yes, these are things you're going to have to deal with. But it all comes down to because you have coupling between services. And lastly, C5, which really also relates to versioning, is that you're making changes to one service. You need to adapt those to another service. How you deploy those and schedule those changes all together. You're working between and coordinating between different services or teams. I do think this paper and Service Weaver really do address kind of the pain points that are out there in the real world in our industry that people are experiencing. The problem I have is that there's not enough emphasis on the coupling between services or your components. That's what is the root of all these pain points, and that's what actually needs to be addressed, is how you're coupling, when you're coupling, the degree of coupling. So are we going to have, I don't really care if it's RPC or messaging, you still have coupling, but deciding what a boundary does and why does it need to call another service? Why does it need data from another service? Deciding, should I need that? Does that need to be an RPC call? Should that be an async driven message via event-driven architecture or queues? But these are all explicit decisions that you need to make that tooling is not going to solve for you. So we're making the distinction between logical and physical boundaries. Awesome, great, I couldn't be happier. But we cannot gloss over about how we're coupling and communicating between these boundaries. What do these boundaries actually do? Are they too small? Are they too large? That's actually the conversation that needs to be happening, not glossing over the fact that I have this logical boundary, there's coupling out of hand between this whole monolith that I'm going to deploy as microservices. You're not going to end up, I don't think, in a better place. If you've been using something like Service Weaver with success or not, let me know in the comments. I'd love to hear it because I do think there are spots that make sense given that you're acknowledging the coupling. If you find topics like this interesting and you want to chat with other software developers, you can join my channel and get access to a private Discord server. Check the link in the description on how to join. If you found this video helpful, give it a thumbs up. If you have any other thoughts or questions, make sure to leave a comment. And please subscribe for more videos on software architecture and design. Thanks.